So notice that some values in our table don't exist. That means that the angle t value isn't in the domain of the function. So what do you think the domain of these functions might be? So first, let's look at sine of t. So we have 0, 1/2, square root of 2 over 2, square root of 3 over 2. And so we know that sine of our angle is going to be the height. And although we can have a height of 0, there's never a place where our height is not going to exist. We always have some sort of height, even if it's 0. So the domain of sine of t is all real numbers. Same thing with cosine of t. Our cosine of t we can think of as the length or the width maybe. So that is all real numbers. And then we have tangent. And notice that at pi over 2 we did not exist. So let's examine this. Why at pi over 2 didn't we exist? Well, remember that tangent is y over x. So when we have values of 0 for x, we have a problem with our domain. And so when we hit pi over 2 and 3 pi over 2, and then we have to remember that we can go back around to hit 5 pi over 2 and back around to hit 7 pi over 2. So our domain is all real numbers except pi over 2 plus, so we get to pi over 2 plus adding any multiple of pi. So n right here is going to be an integer. So 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, all of those numbers. Next we look at cosecant. So where do we have problems with cosecant? Well, that is where we have 1 over y, so when y is 0. So where is my y value 0? Well, that happens at 0 or 2 pi and pi. So we have all real numbers except any integer times pi. And secant is very similar to tangent because secant is where we can't have an x in the denominator. So secant and tangent have the same values, have the same domain. And cotangent, what do you expect? If that's x over y, you'd expect it to have the same domain as cotangent. So remember that the values that we don't have in our domain are when we have a 0 in the denominator.